welcome back, my seventh graders. Let's go ahead and work on our homework. I've got all the odd ones as usual. We're following PEMDAS here to solve this expression. There's no parentheses or exponents, so I'm going to go to multiplication. Multiplication is here. I see that I got a 7 on the top over here and 7 on the bottoms. Since both of these are divisible by 7, I could take 7 divided by 7, leave 1. I could take 7 divided by 7, leave 1. I can also take 4 and 2 and say that they're both divisible by 2. So I'm going to take 2 divided by 2, and that leaves me 1. And 4 divided by 2, that leaves me 2. And now I can go ahead and solve the first part. Negative 1 times 1, that's going to be negative 1. And 1 times 2, that's going to leave me 2. Now I'm going to add this to 5 over 6. Now I can go ahead and do my addition and subtraction. I see that I have a two fraction with different denominators. So what I'm going to do is take 2, since I can multiply 2 to 3 and get 6, I'm going to do that. And remember, whatever I multiply the bottom, I have to multiply the top, because I'm only allowed to multiply things to 1. 3 divided by 3 is 1. So this is going to rewrite this whole thing. This is now going to become 3 times negative 1. That's a negative 3. And 3 times 2, that's 6. That'll be added to 5 over 6. Now, this is an addition problem, and 5 minus 3 equals 2. And our 6 stays the same because it's our denominator. And both of these are divisible by 2. So I can simplify this. Now this will become, well, 2 divided by 2 is 1, and 6 divided by 2 is 3. So my answer, excuse me, my answer is 1/3. All right, that's how I do number 2, or number 3, excuse me. Once again, following PEMDAS, if I try to do parentheses, there's nothing in the parentheses to do. No exponents, I go to multiplication next, right here. I'm going to take these and multiply them to each other. Let's see, I'll take 2.9, multiply it to 1.4. And remember, a positive times a negative will give me a negative answer. So I'll put a negative over here. Uh, 9 times 4 is 36. 2 times 4 is 8, plus 3 makes 11. I put my 0 here. I remember I have 29 over here, because anything times 1 will be itself. When I add these up, I get 6, 0, 4. And now I have to remember to move my decimal places, 1, 2 spots. 1, 2 makes negative 4.06. So now I have 3.3. I didn't do anything with this. And I have negative 4.06. Now I have a subtraction problem. Remember, when I subtract, I take the big number minus the small number, keep the sign of the big number. So I already know my answer is going to be a negative. So I'm going to come over here, take the big number, 4.06. And I'm going to subtract the small number, 3.3. Remember to line up your decimals. This will be 6. And then I have to borrow 1 here. And 10 minus 3 is 7. So this is 0.76. Remember, our answer has to be negative, so it'll be negative 0.76. So that's my answer for number 3, negative 0.76. Number 1 was, of course, 1/3. All right, I got to do number 5 next. It says, what are the numbers from least to greatest? Give myself some room here. If I do this, I have to turn these all to decimals to find out which one's the biggest. Let's take 15% and start with that one. 15% as a decimal is moving my decimal spot 2 spaces. So this becomes 0.15. I have 14.8 already as a decimal. I'm sorry, that's 14.8. Okay, so I don't need to do anything with that. Next, I have 5 and 4/8 or 4/5. So I can remember that my decimal is going to start, or my number is going to start with 5. I got to find out what the 4/5 is for my decimal. 4/5 is 4 divided by 5. So I can come over here and take 4 divided by 5. That's going to give me 0.8. So this would be 5.8. And next, oh, remember that was 15 and 4/5. Okay, and now I have 14 point, excuse me, 1,450%. Make the decimal out of that by moving my decimal place 2 spots. This would become 14.5. Some of you are saying, how about the 0, Mr. Mendez? I don't put zeros. I mean, for that, I could put zeros forever, right? All right, so now I got to go from least to greatest. The smallest number here is definitely going to be, I'm sorry, I thought this was a 5 and 4/5. It's actually 15 and 4/5. So this would be 15.8. So the smallest number here is definitely 0.15. So that's going to be my 15%. My next smallest number is going to be my 14.5. But remember, that was 1,450%. So I got to write that as they gave it to me. All right, that's gone. That's gone. My next smallest number will be 14.8, which was already given to me as a decimal. And of course, the last one then is 15.8, which was 15 and 4/5. Remember, when giving your answers, do not give them in the evaluation that you found. Give them in the form that it was given to you. All right, we're going to number 7. Number 7 says, determine whether the expressions are equivalent. Explain your reasoning. So I have to see if expression number 1 and expression number 2 are equivalent. First, I got 3 minus 5x. I can't do anything to this because these are not like terms. So that's the simplest expression. But then I have 4.25 minus 5x minus 4.25. It's kind of weird that they would have this because remember, I'm allowed to go ahead and turn this into all addition by using inverse operations. So now I could take 4.25. I can make this plus negative 5x. And then I could say plus negative 4.25. You might say, why did you want to do that? And the answer is simple. When I'm adding, I'm allowed to mix all my numbers around. So now I can take these two, 4.25, and negative 4.25, and put them together. The reason I'm doing that is so I can see that I'm taking away the same number, right? So if that's true, I have 0. Now I have 0 plus negative 5x. And 0 plus anything is the number, so this is just negative 5x. So my second expression is negative 5x. My first one is 3 minus 5x. So these are not equivalent. So no, they're not equivalent. Okay, because I'm just going to type this out. Because well, 3 minus 5x is, let's see, not equivalent to, I could just put this symbol here, not equivalent to, and then continue typing here, and I could put negative 5x. Okay, oh, this should have been a negative, I apologize. All right, let's go to number 9 now. Identify the terms and like terms in the expression, okay? So let's do this first. Identify the terms. The terms, I'm going to type this out. Terms, they are t. They're also 8 and 3t. All right, now it says, and the like terms. So the like terms are p and 3t. I know they're like because they both have t, that variable, to the same power, right? All right, let's go to number 11. If I'm doing this one, and it's the same way, first I'm going to do my terms. I guess that over here, instead of putting a comma, I should have put equal sign maybe, right? Let's do that over here. Terms equal, this one has 2n, a negative n, a negative 4, and a 7n. So the like terms equal, I guess if I was going to fix this one, well, I put r here, that's the same thing. The like terms are 2n, negative n, and 7n. They all have n to the same power. All right, let's go to number 13. And I see my terms equal 1.4y, 5, negative 4.2, negative 5y to the second power. Let's see, 5y to the second power. insert here. It's not going to let me do that, so I'm going to have to put -5 to the second power. And then z. And now, what are my like terms? Well, my like terms are going to be I've got, let's see, there's nothing with y at the end to match anything else. Oh, I'm sorry, we did have y to the second power here, didn't we? So let me move that a little bit here. And we'll put y to the second power. That was not just -5 to the second power. Okay, these y's are not to the same power. So they're not like terms. They are not identical. So that means my only like terms are going to be my constants, my numbers. So that's going to be, let's see, 5 and -4.2. Now you might be saying, Mr. Mendez, but this is a negative number. It has a decimal. Remember, we don't treat our rational numbers any different than we do our integers. Numbers are numbers. Okay, all numbers matter. So we're going to say that these are both rational numbers. So I can put them together. All right, let's go to number 15. Your friend identifies the term or like terms in the expression. Is your friend correct? Well, my friend says my terms are 3x. That's correct. 5, 2x, and 9x. That was incorrect because this term here starts with a negative number. We have to remember that that negative sign belongs to the 5. So in actuality, that should have been a -5. So was he correct in my like terms? Yes, all the like terms. No, actually, no. I see another mistake. And this, go back here. I also see that -2. Oh, sorry about that. -2x also has a negative in front of it. So this is going to be negative as well. So the answer is no. He should have stated the terms were 3x, that part was correct, -5x, or -5, excuse me, -2x, and 9x. Okay? And as far as getting all those like terms correct, let's see, so that was incorrect as well. Let's see, over here. And the like terms should have been 3x, -2x, and 9x. All right, let's go on to number 17. Simplify this expression. I love these. These are very easy. There is no other x over here, so I can't combine that. 11x will stay the same. And I know that 9 minus 7 is 2, because these are both constants, both numbers with no variable. I can combine them. Big number minus small number is 2. Keep the sign of the big number. And I'm going to number 19. These is 4b. There's no b over here, so 4b will come down by itself. Now we take the big number minus the small number because we have different signs. That'll be 24 minus 19. That's going to equal 5. So since the negative 24, uh, since the negative with the bigger number, this would be a negative 5. Number 21, it says I got 4.2v minus 5 minus 6.5v. So I'll take the v's and put them together. I take the big number, 6.5, minus the small number, 4.2. And that's going to give us 2.3 v. And the negative 5 comes down. Okay? Let's see here. Let's go to number 23 now. I've got four terms to combine now. I got two of them with y with them. So I'm going to do them first. I'm going to take I got to find out which is the big number. First, I'm going to have to say, let's see, I got 2 over 5y. And I have negative 9 over 10. I need a common denominator, so I'm going to multiply this to 2, so it will become 10, which means I multiply the top to be 2. And now this will be 4 over 10y minus 9 over 10. Y, excuse me. So now I can go ahead and say that I'm going to take the big number minus the small number. 9 minus 4 is 5. I keep the sign of the big number. The big number was negative, so this would be a negative 5. So now that part is negative 5y. Negative 5 over 10y. And I can actually simplify that further because both 5 and 10 are divisible by 2. I can say this is negative 1 over 2y. And I'm sorry, I said 2, but they're both divisible by 5. 5 divided by 5 is 1, 10 divided by 5 is 2. So it's a negative 1 over 2y. Now I got to deal with my constants here. I already took care of these. And negative 4 plus 7. Well, remember we take the big number, that's 7, minus the small number, that's 4. That gives me 3. I keep the sign of the bigger number, that was positive. So my answer is negative 1 over 2y plus 3. All right, let's go to 25. Each hiker carries the items shown. Write and interpret an expression in simplest form that represents the weight carried by X hikers. How much total weight is carried when there are 4? So first it says write and interpret an expression in simplest form that represents the weight carried by X hikers. So I'm going to take 3.4. I guess that'd be X. I don't know how many hikers there are, but each hiker will carry that. I'm going to add it to, let's see, 2.2. X. I'm going to add that to 4.5 X, right? If I put these numbers together, 3.4 plus 2.2 plus 4.5. Let's see, well, 5 plus 2 is 7. 7 plus 4 is 11. I've got 4, 8, 9, 10. So each hiker carries 10.1, so that's times X, okay? Now how much, if there are 4 hikers, so this is going to be 10.1, we're going to multiply that to 4, okay? So let's see, 10.1 times 4, 1 times 4 is 4, 0 times 4 is 0, 4 times 1 is 4, and now our decimal place is 1, so it comes back 1 here. So that means that each hiker is going to carry 40.4 pounds. Okay, let's go to number 27. Write an expression with 5 different terms that is equivalent to this one here. Write an expression with 5 different terms that's equivalent. Well, there's a lot of different ways to answer this. I guess I'll answer it the way the book does, so it matches yours, but hold on a second. All right, so according to the book, you'd have this. They're saying 8 plus 2 times x to the second power plus 9x to the second power. And that makes sense because 2 plus 9 equals 11x to the second power. I'm trying to figure out where they got that from. I got 3 here. Then it says plus 3y minus 8. Let's see, an expression with 5 different terms that is equivalent to this. Does this really work here? I'm going to have to check and see here. They're saying because this is going to equal 11x squared, and that's what I got when I added these, plus 3y, and that makes sense because 8 minus 8, okay, will be 0. And now they're saying when you take, oh, I see, because they have 8x to the second power plus 3x to the second power. That will equal 11x. So they did it kind of tricky there. I'm going to make it a little bit simpler for mine. I could just as well write an expression 5 different terms that's equivalent to this. You really could have just put 8x squared plus 3x squared. I know this looks very familiar. Plus 3y. It could have been just as easy as this. Minus, just like they did over here, minus 8, and then plus 8. This is 5 terms. 1, 2, 3, 4, 5. Yep. Does it equal the same thing? Yes, because 8 minus 8 will give me that same expression that they have here. All right. That's kind of weird the way they did it, but I'm hoping this one makes it a little easier to see. Let's go ahead and move down to number 29. Choose a method. 2 comets orbit the Earth. One comet travels 30,000 miles per hour. Okay. The other comet travels 28,500 miles per hour. What is the most efficient way to calculate the difference of the distance traveled by the comet for any given number of minutes? Okay. Justify your answer. I'm sorry I had to stop the video for a minute because I was trying to figure out where all this car and truck and car wash came from. This has nothing to do with this problem, so I'm just going to mark it out. It was obviously meant for a different problem, maybe over here with car washes and stuff. So this probably should have been for this problem over here, and I apologize for that. But now you know how to do number 30, and I'm going to go ahead and show you how to do number 29. All right. I'll tell you now that if I'm going to take these 2 comets, remember it says write the most efficient way to calculate the difference. I'm going to subtract. First, the difference is the answer to a subtraction problem. I'm going to take 30,000 minus 28,500. That's going to give me 1,500, right? And that's per hour, 1,500 miles per hour, right? So it's a ratio, it's 1,500 over 1 hour. Remember, it's telling us to convert it into minutes. So I'm going to have to take this now and say that 1 hour is equal to 60 minutes. All right. So I can, there's 1 hour on the top, one on the bottom. I would take 1,500 and divide it by 60 to get my answer. Okay, and 1,500. Well, it says, what is the most efficient way to calculate it? So it's 1,500 divided by 60. Okay. So let's put this over here. And that looks like that's not going to work. So I'm going to type in my own answer here. I was hoping I just copy and paste from the book. My answer is going to be divide the distance traveled by each comment. No, subtract, I'm sorry. Subtract the distance traveled by each comment and divide that answer by 60, because there are 60 minutes in 1 hour. All right, and that's how I would do it. Let's see, looks like 30, 20, or 30 is yours, 29 is for me to do. It says, problem solving, you add gold foil to a piece of red poster board to make the design shown. Find the area of the gold foil when x equals 3, justify our answer. Okay. I'm glad I looked into the book for this. I see that I actually forgot a very important piece of information. That's the illustration that went with it. I'm going to add that to it now. All right, so find the area of the gold foil when x is 3. So first, let's realize that area is going to equal length times width. So if I'm finding this, I have to take 20 and multiply it to 12 first to get the whole thing. 20 times 12 that's going to equal 240. So first I'm going to put that 20 times 12 equals 240. So that's the area of everything. Next, I got to find how to subtract the red from it, right? Because it says find the area of the gold, only the gold part. So let's see. I know the area of this red one is going to be 12, right? See, 12 times x, right? Because we got 12 here. We're multiplying it to x over here because only this distance, right? So for this one here, it's 12 and then times x. And then over here, it's going to be 20 times x, right? So 12x, let's see, plus 20x. But we have to remember this is a part of each of them. So I got to subtract that from this amount. This is x, and this is x, so this is going to be x times x. So this would be minus x squared, because x times x is x squared. This is going to equal 32x, because 12 plus 20 is 32, right? And that's the same term, minus x squared. Okay. Now let's remember we're looking for the formula up here, which we said was going to be the whole thing minus this. That's going to be, well, let's see, 240. Remember that was the entire area, right, of the whole thing. We're minusing, well, this is going to be 3x minus x squared. Okay, I know when I have a negative in front of parentheses, I have to multiply it to everything in there. So this is going to be 240. A negative times 3x would be a negative 3x. Then a negative times a negative x squared would be a positive x squared, because a negative times a negative is a positive. And that's going to be my expression, right? That's how much it is. And now I'm saying x is 3. So I'm going to replace x with 3. This should give me, I'm sorry, I put 20 over here. It should have been 240. Let's fix that up really quick. Wow, I totally messed that up. 240. So that'll be 240 minus 3 times, remember x we said was 3, plus, then it's saying x, which is 3, excuse me, squared. So this is going to be, wow, I keep messing up this 240, don't I? Let's see here. Glad I'm catching all these mistakes so I don't have to hear you guys ridicule me in class. All right, so this is going to be 240. We're going to minus 3 times 3 is 9, right? A negative times a positive is negative 9. And then plus, well, 3 times 3, because 3 second power is 3 times 3. That's also going to be 9, right? Ooh, this is getting a little bit complicated. So let's see, I've got x squared 3, negative 9 plus 9. And I caught my mistake. Sorry, everybody. I must be really tired. This was 32x, not 3x. I'm going to have to rewrite this. Bear with me here. 32x. I was wondering what went wrong, because if I took 9 minus 9, I would have got the same answer. It's impossible for that to be it, because I had to subtract something. So this is 32x, right, minus x squared. So I have to rewrite this now to show it's going to be a negative 32x plus x squared, which means I'm rewriting all of this again. You're probably thinking, Mr. Mendez, you're driving me crazy. It's 32 times 3, because x is 3, plus 3 to the second power. That's going to change this last part quite a bit, because 3 times 32 will be negative 96, and plus 3 squared is still 9. So that middle term, that changed a lot by me missing that 2 there. So now let's go ahead and do this. We're taking 240. We're minusing 96. Actually, why don't we add the 2 positive terms first, right? Because we can rewrite this whole thing. Actually, just we could put 240 plus 9 plus negative 96. So 240 plus 9, well, that's easy. That's 249. And now I'm going to subtract 96. And that's going to give me 3. I've got to borrow 1. 14 minus 9 is 5. That should give me 153. These are inches. 153 inch. What does it say? Find the area. So that's going to be square. And then B says the pattern at the right is called the St. George Cross. Find the country that uses this. I just happen to know that it's England. Okay, is there any more for Mr. Mendez to do? Nope, that last one's all you. All right, we'll grade the rest of these in class. Have a great night and see you in class.